Okay, welcome back to the third lecture this morning. We're going to hear a continuation of the fascinating story we've just heard. It's going to be focused on the engineering aspects of the equipment that was involved in the Phoenix experiments, and Preston Nichol is going to be our next speaker. Preston received his BSEE engineering degree and is the director of the Space-Time Laboratories. He has been studying the interaction between subtle energies and psychotronics and psychic activities for nearly 20 years. He is the originator of the Bioson radionics broadcaster, BioPhys bioactive sound system. He's been investigating the Phoenix project at Montauk Point, which we just heard about. And he's an old-timer to the psychotronics group here, and he's going to talk to us today about the specifics involved in the equipment that was used in the Phoenix project. Welcome, Preston Nichols.
Good morning, people. You already know who I am. I think we'll say at this point that our purpose here is not to prove whether or not this project happened. What we are here is to discuss what they did, how they did it. Mr. Billick already discussed very well what they did. So we'll go into the meat of it. Essentially, the Montauk project was a very large mind amplifier. That's essentially all it was. I have here a very simplified block diagram.
You get back up on the platform and get you.
Well, the trouble is I'm having trouble seeing the diagram.
Okay, go ahead.
I can be right here. All right. Very simplified was essentially a transmitter. We had an input network, which was the Montauk chair, that's what we called it. Mr. Cameron, sitting over there in the red shirt, was the psychic that sat in the Montauk chair and fed information into the computer system. The computer system essentially processed the information and spit it out to the transmitter. We had two transmitters, drove one of two antennas. There was also a Delta T antenna and a 100 kilowatt noise amplifier. This was the basic outlay of the Montauk system. Nice feedback. We will first discuss the Montauk chair. There was two versions of the Montauk chair. The Montauk chair was developed by ITT, World Communications, for the government, or whoever developed this project. The chair had essentially three coils in it. You can see the Y coil went like this under the floor, formed two sides of a pyramid, came out. Another coil came up, formed the other two sides of the pyramid, came out. The third coil was essentially two coils, one on the floor and one on the top. These provided three outputs of essentially an RF signal. The signal looked like white noise, essentially. But the correlations in the white noise was the information of what the person had in his mind sitting in the center of the pyramid. I have to apologize for my drawing. It isn't all that great. This should be right under the point of the pyramid. And the receiver system looked essentially like this. You had your three loops. You had your three basic receivers. They used a very standard type ISB detector system using the phantom type lock. How that worked, we had the receiver, which we'll have a more detailed diagram of. We had the carrier processor, which was essentially a very narrow band filter that converted from the IF of the receiver down to a very low frequency signal. They had the discriminator, which would just essentially form an AFC loop between the receiver, the local oscillator, which was injected into the receiver, and the thing would lock up on theoretically a pilot carrier that was transmitted from the transmitter. But of course in this system there was no pilot carrier, so it essentially attempted to do a lock on the noise, and this made the whole thing coherent essentially based upon the noise. And then the output came to the ISB detector. You had the carrier injection. You had 3 of these channels with 6 outputs. This is a detail of how the receiver system worked. The basic receiver, the SP600, was a standard type receiver with a pre-selected RF amplifier mixer. The yellow was switched out of the circuit. That was from a separate assembly. Had 2 IF sections, second mixer. And the BFO CW detector became a third mixer, supplied 25 kC. You can see the carrier processor had limiters and 20 hertz bandwidth filters and all that neat stuff, which is very much similar. Technology was used quite commonly in the 50s and 60s and the 40s to receive communication signal. They converted down to 2 kilohertz again, went through another limiter, went through a discriminator, very similar to what's in your FM radio. That's why we show the S-curve. That's how we show a discriminator. Went back into an FM reactance modulator to the yellow stage, and this whole thing locked up. There was a 25 kilohertz crystal oscillator, which supplied the carrier for the detector. The signal came out 25 kilohertz, went through filters that were very closely matched for phase and frequency response, and provided the 2 outputs. This was the first chair. They had problems with this chair inasmuch that this coil structure was open. It picked up from outside as well as from inside. They had to locate this chair at Southampton, which was about 15 miles away from Montauk, so it wouldn't feed back to the transmitter. The thing would feedback, lock up, and cause all sorts of problems. So they had taken the output of the Cray 1 computer and microwave linked it over to Montauk. Of course, if you had any sort of little time glitch, reality glitch go through the microwave beam, this thing was spitting back information at such a rate that it sent the whole system into oscillations and caused all sorts of problems. So they came up with a second version of the chair. Okay, what we can do also is we'll show you the equipment that was used on the first version of the chair. This is a Hammerlin SP600 as modified by ITT. In fact, you can see ITT Worldwide Communications here. This is the back end of it. Anyone knows an SP600 can recognize that this module is different, this module is different, the layout of tubes in here is entirely different. This is the carrier oscillator. You can see Mackay radio, which became ITT. In fact, this piece actually came off the Montauk Air Force Base. You can see the rust on the tubes, because the Montauk Air Force Base was a very damp, rusty place. And you can see this technology is quite old. This is their carrier processor. There's the very narrow band filter. You can see this also came off the Montauk Air Force Base. Of course, the SP600 receiver I still use. These I don't use. In fact, I haven't even fired these things up because I'm a bit afraid to plug these things in. There might be a lot of smoke. This is the discriminator module. Of course, what's on it? ITT. I'm sorry. And this is the upper-lower sideband detector. Of course, what's on it? ITT. This is the back end of that with all the ancient tubes. You know, those are those glass and case FETs. This is essentially what the first chair system looked like. Now, based upon information they've gotten from crash UFOs and technology exchange, whatever, they found out that essentially you could put the victim between a set of Helmholtz coils. Helmholtz coils are interesting because they can be phased as such that the pickup would only be between all the coils and would exclude to some extent all the junk outside. Now, of course, if we go back, we're not going to do it here, to the pyramid antenna structure, this is something known as delta T or delta time sensing pickup type structure. This is one of the things the pyramid does. It does translate time waves. Now, of course, they had to get the delta time structure in the receiver. We'll go into that in a few minutes of how it was actually done.